Good afternoon, students. So today I am doing class 12 science. So today's topic is differential calculus. So we'll start first order derivative. So in class 11 you did the basic concepts of first order derivative. Let us revise it once again. Okay. So this first order derivative is also known as differentiation, or it may be known as differential coefficient. Okay, so it may be first order derivative. The meaning of derivative is it may be differentiation, it may be differentiation, or it may be what? Differential coefficient, right? It may be differential coefficient. It may be differential coefficient. So actually, what is the meaning of first order derivative or differentiation or differential coefficient? So I think you have done it in class 11. Class 11 the definition of the derivative. We can write down the definition of derivative from limit chapter. Okay, so its definition is, let us write it once again. So what is the meaning of differentiation or derivative or differential coefficient, right? So if limit h tends to 0, then function of x plus h minus f of x whole divided by h, right? If limit h tends to 0, f of x plus h minus f of x whole divided by h exists, right? If this limit exists, then the value of this limit, is defined as the derivative. Is defined as the derivative or differentiation, derivatives or differentiation or differential coefficient of the function f of x of the function f of x with respect to x, right? And is written as you have to write it as f dash of x is equal to, that means this limit is defined as f dash of x and is written as f dash of x. That is, f dash of x means derivative or differentiation or differential coefficient of f of x with respect to x, right? So f dash of x is equal to, it is defined as what? Limit h tends to 0, right? Then f of x plus h minus f of x, this whole divided by h, right? So this f dash of x is the differentiation of f of x with respect to x and is defined as limit h tends to 0, f of x plus h minus f of x whole divided by h. Okay, so this is the basics of derivative or differentiation or differential coefficient, right? So we can copy it. This is the definition. So I think you have done it in class 11 also, right? Now, or you may write it as this f dash of x is written as dy by dx if y is equal to f of x. If y is equal to f of x, suppose if y as a function of x, if you write y as a function of x, f of x means function of x, right? If y is written as a function of x, then dy by dx is equal to, this is limit h tends to 0, f of x plus x minus f of x this whole divided by h. Right? So I think you have understood it. So you have to copy it. So now, in this case, I have written here if y is equal to f of x, right? That is d by dx of f of x. So what is the meaning of d by dx of f of x? That is differentiation of f of x with respect to x. It is defined as its formula is f dash of x, right? D by dx of f of x is equal to f dash of x. Or what is f of x out here? It is y. That is d by dx of y is equal to f dash of x. That is dy by dx is equal to, it is f dash of x, right? So that's why we have written here f dash of x is equal to dy by dx, right? So f of x, differentiation of f of x with respect to x is defined as f dash of x. Okay? So now let us write down the formula that you have done in class 11, because we need all that formula in class 12 while doing this chapter. Okay? So let's revise all the formulae that we have done in class 11, right? Now formulae. So formula number 1, that is d by dx of constant. What do you mean by constant? Actually the variables are taken as x and y, and constant c. So constant is taken as c. Constant means which are free from x and y. The terms which are free from x and y are known as constant. What is the differentiation of? It is read as differentiation of constant. This is with respect to x, that is 0. Differentiation of constant, this dx means with respect to x. Differentiation of constant with respect to x is 0, right? Number 2, d by dx of x to the power n. Here n is constant, right? So what is this formula? N comes in the front, x to the power n minus 1. This is number 2. Number 3, d by dx of x. Can you tell me what is d by dx of x? It is just like x to the power n. This is x to the power 1. If you use this formula, 1 comes in the front, x to the power 1 minus 1. You know that what is x to the power 0? It is always 1. So d by dx of x is always 1. Number 4, d by dx of root over x is equal to 1 by 2 root x. You know this formula from class 11. This is x to the power half. Use this formula. Half comes in the front, x to the power half minus 1. If you simplify it, you will get 1 by 2 root x, right? The next, number 5 is, what is number 5? Let us write number 5, d by dx of a to the power x. Here the base a is a constant and power x is the variable. Its formula is a to the power x log a base e. It is a to the power x log a base e. Is that clear? What is the differentiation of a to the power x with respect to x? It is a to the power x log a base e. You cannot write here x into a to the power x minus 1. You cannot use this formula. You cannot use it. Use this formula, right? That is here x base is the variable and power is the constant. In this case, the base a is constant, the power x is the variable. That is number 5. Okay? And number 6 is d by dx of e to the power x. That is exponential function, which is e to the power x, right? And formula number 7 is d by dx of that is your log x base e, which is equal to 1 upon x, right? And now number 8, now we can write on the differentiation of trigonometry function. That is d by dx of sine x. What is d by dx of sine x? It is cos x. Now number 9, d by dx of cos x is equal to, if the trigonometrical ratios start from C, then its differentiation is minus, right? Number 10, dy dx of tan x is equal to sec square x, right? Dy dx of tan x is sec square x. Number 11, dy dx of cot x is equal to, what is dy dx of cot x? It is minus cosec square x, because here trigonometric function starts from C. And number 12, dy dx of sec x is equal to, this is your sec x tan x, this is your sec x tan x, right? And last, number 13 formula is, so I'm writing here number 13. Number 13 is dy dx of cosec x. Dy dx of cosec x is equal to, what is the formula? It starts from C, right? So if it starts from C, it's negative, minus, this is cosec x into cot x. So these are the 13 formulae that you have done it in class 11. So you have class 12 में काम गर्छ, बुझ्नुभयो हैन? त अब तिमीले यहाँ अझै फर्मुला थप्नुपर्छ. You did inverse circular function also. You should know the differentiation of sin inverse x with respect to x, differentiation of cos inverse x with respect to x, tan inverse x, cot inverse x, cosec inverse x, and sec inverse x, right? So before that, you should know the function of the function. What is meant by function of the function? Now in class 12, you should do the differentiation of the function of the function. In class 11, you did only differentiation of the function only, but in class 12, you should do the differentiation of the function of the function. Is that clear? So now first of all, before I write down the formula for inverse circular function, you should know about the differentiation of the function. So again, before I do differentiation of the function, you should know what is meant by function of the function, right? So let us do function of the function now. So what do you mean by function of the function? Okay. Now, function of the function. What do you mean by function of the function? Or function within a function is known as function of the function. Okay. Suppose if you have log within bracket sin x. So first of all, log is given, so it is logarithmic function. You know that there are 5 types of functions, that is LIATE, liate, right? LIATE, liate, or it may be ILATE also, ILATE, ILATE also. Okay? L means logarithmic function, I is inverse circular function, right? L is logarithmic function, I is inverse circular function, A is algebraic function, T is trigonometric function, and E is exponential function, right? So L one is logarithmic function L. I one is inverse circular function. So here I is equal to inverse circular function, right? So I is equal to inverse circular function, right? And then A means algebraic function. A means algebraic function. And what is T? T here is trigonometric function. And what is E? E is the exponential function. Exponential function, right? So you should know this word, that is liate or ilate. L means logarithmic function. I means inverse circular function, A means algebraic function, T is trigonometric function, and E is exponential function, right? So you know that logarithm function is written as log x like that. Inverse circular function, it is sine inverse x, right? Algebraic function is, it may be x to the power n. Trigonometric function, it may be cos x, sin x, tan x like that. And exponential function means it is e to the power x. Okay? So in class 11, you did differentiation of the function only. So in class 12, you should do differentiation of the function. So before we do differentiation of the function, you should know the meaning of function of the function. Right? So now, let us take this log of sin x. Okay? So I have written here log of sin x. This function is known as function of the function. Why is it function of the function? So first of all, it is log, that is logarithm function, that is logarithmic function. Within logarithmic function, there is another function, that is sin x, that is trigonometric function. So within logarithmic function, there is another function, trigonometric function, that is sin x. So this type of function is known as function of the function. Okay? So next example is e to the power sine x to the power n. Now first of all, which function is written here? E. That is your exponential function. Within exponential function, there is sine x to the power n, that is your trigonometric function. And within trigonometric function, there is another function which is x to the power n, that is your algebraic function. So this is the function of the function of the function. But we don't say this as function of the function of the function. We just say this is also function of the function. Is that clear? Within exponential function, there is a trigonometric function. Within trigonometric function, there is another function that is known as algebraic function. So this should be actually function of the function of the function. But we don't say function of the function of the function. We just say this one is function of the function. So next example is sine inverse log x, right? So sine inverse, first of all, it is the inverse circular function. Within inverse circular function, there is another function that is known as logarithmic function. This is also known as function of the function. Okay? So these are all the examples of function of the function. Now, let us find out the differentiation of the function of the function. Okay? So suppose if you want to get the differentiation of log of sin x, right? So how can you get the differentiation of log of sin x with respect to x? How can you find out the differentiation of log of sin x with respect to x? That is d by dx of log of sin x. Okay? So how can you get its differentiation? So we can write on the formula from formula number 1 to 13. We have just written it here, isn't it? That is from number 1 to 13. We have just written it out here, isn't it? So formula number 1 to formula number 13, right? So how can you find out the differentiation of log of sin x with respect to x? First of all, log is given. Take it as log x. We should use the formula from formula number 1 to 13 itself. Okay? So first of all, d by dx of log of sin x is written out here. Okay? So how can you differentiate it? First of all, you should take it as log x. What is d by dx of log x? It is 1 upon x. So in this case, which function is assumed as x? Sin x. Okay? So पहिला हामी यसलाई के लिनुपर्छ? Log x भनेर लिनु. So what is the differentiation of log x with respect to x? It is 1 upon x. 1 upon, but what is x here? Sin x. Okay? Now in this case, the function which is assumed as x should also be differentiated. जुन चाहिँ फंक्शनलाई तिमीले x मानिलिएको छ त्यसलाई फेरि डिफरेन्सिएट गर्नु. त xn को लागि हामीले केलाई मानिलियो? x sin x लाई. त्यो sin x लाई हामी फेरि डिफरेन्सिएट गर्छौं with respect to x. So how do you write it? d by dx of sin x. Okay? So is equal to 1 upon sin x into what is d by dx of sin x? It is cos x. So what is cos x by sin x? It is cos x. Is that understood? So how can you differentiate d by dx of log of sin x? How can you differentiate log of sin x with respect to x? First of all, log function is there. Let us take it as log x. Which function is taken as x? Sin x is taken as x for the time being. Okay? So x को लागि हामीले यो sin x लाई हामीले x लियौं. So what is the differentiation of log x? It is 1 upon x. But we cannot write x here because instead of x there is sin x. So it is 1 by sin x. And also the function which is assumed as x is also to be differentiated. That is, you have to differentiate sin x with respect to x. जुन चाहिँ x मानि लिएको छ त्यसलाई हामी फेरि डिफरेन्शिएट गर्छौं into d by dx of sin x. So what is d by dx of sin x? It is cos x. So what is cos x by sin x? It is cot x. So let us take another example. So I think I have understood it. Let us take another example, that is this one. Oh, this one, second one. Not this one, okay? This is inverse circular function. We haven't done the differentiation of inverse circular function, okay? So d by dx of e to the power sin x to the power n. Now, how can you differentiate e to the power sin x to the power n with respect to x? First of all, which function is there? Exponential. Let us take it as e to the power x because you know only the differentiation of e to the power x, isn't it? What is the differentiation of e to the power x? It is e to the power x. Which function is taken as x here? This is sin x to the power n. The function which is assumed as x is also to be differentiated. That is, which function is to be differentiated here? Sin x to the power n. किनभने यो sin x to the power n लाई नै हामीले x लिएको हो. र into कसरी छ? d by dx of sin x to the power n. Is that clear? So now is equal to e to the power sin x. So now, in this case, this is e to the power sin x to the power n into, so how can you differentiate d by dx of sin x to the power n? You should take it as sin x. So which function is taken as x? X to the power n function is taken as x. So it is sin x. So what is the differentiation of sin x? That is your cos x. But here you cannot write cos x. Instead of x, you have to write x to the power n because instead of x, here it is x to the power n. Now, which function was taken as x? It is x to the power n. That function is also to be differentiated. That is, जुन चाहिँ हामीले x मानिरहेछ त्यसलाई फेरि हामी के गर्नुपर्छ? डिफरेन्शिएट गर्नुपर्छ into d by dx of x to the power n. Is that clear? So which is equal to e to the power sin x to the power n into cos x to the power n into, what is d by dx of x to the power n? It is n into x to the power n minus 1. Is that clear? So this is the differentiation of the function e to the power sin x to the power n. Is that clear? So now we will do differentiation of inverse circular function. Okay? So now we will do differentiation of inverse circular function, right? So now in class 11 you did formula from formula number 1 till formula number 13, right? So let us start from formula number 14 here. So you should know all these 13 formulae, that is formula number 1 to formula number 13, you should know all these formulae, plus now formula number 14, that is dy dx of sin inverse x is equal to, what is the formula? It is 1 upon root over 1 minus x square, right? So this is the formula for differentiation of sin inverse x with respect to x, right? That is dy dx of sin inverse x is equal to 1 upon root over 1 minus x square. Now number 15, dy dx of cos inverse x. So the formula for sin inverse x and cos inverse x are similar, but they are of opposite sign. If the inverse circular function starts from c, so it is negative, minus 1 upon root over 1 minus x square, right? And number 16, dy dx of it is tan inverse x. So you should know the differentiation of tan inverse x, that is 1 upon 1 plus x square, right? And let us write down the differentiation of cot inverse, dy dx of cot inverse x. So here also differentiation of tan inverse x and cot inverse x are similar, but they are of opposite sign. If inverse circular function starts from c, then it is negative. So it is minus 1 upon 1 plus x square, okay? The tan inverse x differentiation or cot inverse x differentiation is similar, sir, but they are of opposite sign. If the inverse circular function starts from c, so it is negative, okay? So number 18, dy dx of sec inverse x. So you should know the differentiation of sec inverse x with respect to x. The formula is 1 upon x root over, it is x square minus 1, right? And also the differentiation of cosec inverse x and sec inverse x are similar, but they are of opposite sign. So in number 19, so dy dx of cosec inverse x is equal to, it is just like your sec inverse x, but it is of opposite sign because it starts from c here. So minus 1 upon x root over x square minus 1, okay? So here also the differentiation of sec inverse x and cosec inverse x are similar, but they are of opposite sign, okay? So now if the trigonometric function or inverse circular function starts from c, its differentiation is negative, okay? Now for sin inverse x and cos inverse x, formula are similar, but they are of opposite sign. If it starts from c, negative. Tan inverse x and cot inverse x is differentiation are similar, but they are also opposite sign. If it starts from c, it is negative, and these are also of opposite sign. For cosec inverse x, it is negative. For sec inverse x, it is positive. Okay. So in class 11, we proved all those formulae from number 1 till 13. Now in this case, we will prove this differentiation of inverse circular function, that is from formula number 14 till formula number 19. Now let us prove it here. Okay. So now I just told you about differentiation of the function, isn't it? So that method is used in order to prove this differentiation of inverse circular function. Is that clear? So now you should know all the formula from formula number 1 till formula number 19 now, right? So let us prove formula number 14. So how will you prove it? D by dx of sin inverse x is equal to 1 upon root under 1 minus x square. Let us prove it. Okay. So this is proof of formula number 14. Right. So let us assume let y is equal to sin inverse x. Right. So let us take this sin inverse to the left hand side. So what does it become when this sin inverse x is taken to the left hand side? It becomes sin y, isn't it? So or it is sin y is equal to x. Is that clear? Now let us differentiate it with respect to x. So right now differentiating both the sides with respect to x. Okay. Therefore, dy dx of sin y is equal to dy dx of x, right? Or, what is dy dx of sin y? Now, this is sin y, but you are differentiating it with respect to x. So, let us take this y as x. Okay? So, what is the differentiation of sin x? It is cos x. So, what is the differentiation of sin x? It is cos x. But you cannot write x here because instead of x, what is here? Y. So let us write y here. Again, the function which is assumed as x is also to be differentiated, as I told you in the previous problem, in the previous example, isn't it? तो यहाँ मैले के भन्नु खोजेको भन्दाखेरि dy dx of sin y हामी कसरी निकाल्छौं? पहिलालाई sin x सम्झिनु. What is the differentiation of sin x? Cos x. But can you write cos x here? Instead of x there is y, so you should write here y. Again हामीले कुन चाहिँलाई x सम्झेको y लाई, त जुन चाहिँलाई x सम्झेको छ त्यसलाई फेरि डिफरेन्शिएट गर्नुपर्छ. The function which is assumed as x is also to be differentiated. तो यहाँ हामीले y लाई सम्झेको नि त x, त त्यसलाई फेरि डिफरेन्शिएट गर्नु with respect to x. That means dy dx of y. Is that clear? So which is equal to, what is dy dx of x? That is 1. So I think you have understood it. So, or what do we get? Now let us take this cos y to the right hand side. So it is cos y into, when this cos y goes to the right hand side, you should write it in the denominator. So what is the value for dy? So what is the value for dy by dx? What is dy by dx of y? Actually it is dy by dx, right? So it is dy by dx is equal to 1 upon cos y, right? But you should get the value for dy by dx in terms of x. Okay? So we are getting here the value for dy by dx in terms of y. But you should convert this cos y in terms of x. But you know that what is the value for sin y? It is x. But you can convert this cos y in terms of sin y, isn't it? What is the formula for cos y? It is root over 1 minus sin square y. So or you write dy by dx is equal to 1 upon root over, this is 1 minus sin square y. Is that clear? This is the formula. Now you can put the value of sin y. What is the value of sin y here? It is x. So or dy by dx is equal to 1 upon root over 1 minus x square. So is that clear to all of you? So now therefore dy by dx of, you put the value for y. What was the value for y actually? It is sin inverse x. So it is sin inverse x is equal to what? So what is there on the right hand side? It is 1 upon root over 1 minus x square. So we have proved it. Okay. So what is dy by dx of sin inverse x? It is 1 upon root over 1 minus x square. Is that clear to all of you? So we can copy it. So let us prove. Let's prove the other one. So now formula number 15 and 16 are your homework. Okay, this is 14, so 15 and 16 are your homework. You can do it. Now let's do formula number 17. Okay, so now what was 17 formula? Proof of 17 number formula, that is dy by dx of cot inverse x is equal to, what was the formula? Minus 1 upon 1 plus x square, right? So let us prove it now. The method is same as we have done it in problem number 14 or formula number 14, right? So let y is equal to cot inverse x. Always assume this cot inverse x as y. Now cot inverse taken to the left hand side, what does it become? It is cot y is equal to x. Let us differentiate with respect to x. Differentiating both the sides. Differentiating both the sides with respect to x. Okay. So therefore it is dy by dx of cot y is equal to, this is your dy by dx of x, right? So now you tell me, what is dy by dx of cot y? With respect to x. We are differentiating cot y with respect to x. So you should take this y as x. So it is cot x. What is the differentiation of cot x? Minus cos x square x, right? So it is minus cos x square, but in this case it is y. Now, the function which is assumed as x is also to be differentiated. So, which function is taken as x here? Y. So, this y should be differentiated with respect to x. again. Okay, so dy dx of y is equal to, what is dy dx of x is 1. फेरि हेर अझै एकचोटि बुझाउँदै छु dy dx of cot y हामी कसरी डिफरेन्शिएट गर्छौं अरे तर यो त y छ तर we are differentiating with respect to x. Let us take this y as x, so it is cot x हैन त cot x को डिफरेन्शिएसन कति हुन्छ minus cosec square x. तर यहाँ हामी minus cosec square x लेख्नु हुँदैन के लेख्छौं y लेख्छौं y नै लेख्नु. अब जुन चाहिँ फंक्सनलाई हामीले x सोच्दै छौं त्यसलाई फेरि डिफरेन्शिएट गर्नुपर्छ. कुन चाहिँ फंक्सनलाई हामीले x सोच्यौ y लाई यो y लाई फेरि डिफरेन्शिएट गर्छौं with respect to x. That means dy dx of y. Is that clear? So which is equal to, what is dy dx of x? We are differentiating x with respect to x itself. So which is equal to 1. You know that, isn't it? Now, in the next step, or this is your minus cosec square y into what is dy by dx of y? Dy by dx into dy by dx is equal to 1, right? So what is the value for dy by dx? Minus cosec square y. Only you have to take minus cosec square y to the right hand side. So it is minus cosec square y into dy by dx. When this minus cosec square y goes to the right hand side, you should write it in the denominator. But minus sign you can write it either in the numerator or in the denominator. So or what is dy by dx now? It is minus 1 upon, this is your cosec square y. Is that clear? But you should write dy by dx in terms of x. So how will you write dy by dx in terms of x? So you know the formula of cosec square y, isn't it? What is the formula for cosec square y? It is 1 plus cot square y. So or dy by dx is equal to minus 1 upon 1 plus cot square y. That is, what is the formula for cosec square y? It is 1 plus cot square y. So what is cot square y now? It is x square, right? So or dy by dx is equal to minus 1 upon 1 plus, what is cot square y? It is x square. Cot square y भनेको नि के हो? x square. ठीक छ? So it is proved. Or you may write, therefore dy by dx of, so what is y here actually? It is cot inverse x is equal to minus 1 upon 1 plus x square. So it is proved. Is that understood? Similarly, you can do number 15 and 16. So now you can prove formula number, this was formula number 17. So you can do number 18 as homework. The 18 you can prove it at home. So let us prove number 19. That is proof of 19, right? So what is formula number 19? dy by dx of, it was cosec inverse x, isn't it? Is equal to, its formula is minus 1 upon x root over, this is x square minus 1. Let us prove it now. So now, let us prove formula number 19. So 18 is your homework, okay? That is formula number 15, 16 and 18 will be a homework, and you can revise this 14 and 17 also, okay? So now let us prove dy by dx of cosec inverse x is equal to minus 1 upon x root under x square minus 1, right? So you can use the same method here also. Let y is equal to cosec inverse x. Now let us take this cosec inverse to the left hand side. So what do we get? It is cosec y is equal to x, right? When this cosec inverse goes to the left hand side, it becomes cosec. So it is cosec y is equal to x, okay? Now let us differentiate. Differentiating both the sides with respect to x, right? So therefore dy by dx of cosec y is equal to dy by dx of x, okay? Now how can you differentiate this left hand side? So this is differentiation of cosec y but with respect to x. Here it is y but with respect to x. Let us take this y as x. That is why you should take it as x. So it is cosec x. What is the differentiation of cosec x? You did it in class 11. What is the differentiation of cosec x? Minus cosec x cot x. But in this case, what is x? It is y. So you should write here minus cosec y into cot y. So which function is taken as x here? It is y. The function which is assumed as x is also to be differentiated. हामीले जुन चाहिँलाई x मानिलिएको छौं त्यसलाई फेरि डिफरेन्शिएट गर्नुपर्छ with respect to x. त कुन चाहिँलाई हामीले x मानिलिएको हो y लाई. त y लाई हामी फेरि डिफरेन्शिएट गर्नुपर्छ with respect to x. त कति भयो? Into d by dx of y is equal to, now what is d by dx of x? That is 1. Is that clear? So now next, so write down in the next step. So it is, so write down minus cosec y into cot y, or minus cosec y into cot y into dy by dx. What is dy by dx of dy by dx of y? It is dy by dx is equal to 1. Okay. Now let us get the value for dy by dx, or what is dy by dx is equal to minus 1 upon this is cosec y into cot y. Okay. Now dy by dx is expressed in terms of y here, but you should express the value of dy by dx in terms of x. Okay. But you know that what is the value for cosec y? It is x. So instead of cosec y, you can write x. But you should convert that cot y into cosec y. So what is the formula for cot y in terms of cosec? You know this formula, isn't it? Cosec square y is equal to 1 plus cot square y. You know it from class 10, isn't it? Or cosec square y minus 1 is equal to cot square y. Or what is the value for cot y? It is root over, this is cosec square y minus 1, right? So instead of cot y, what can you write? It is within square root cosec square y minus 1, right? So or dy by dx is equal to minus 1 upon cosec y. Keep it as it is, cosec y. Now write down the formula for cot y. What is cot y? It is within square root cosec square y minus 1. Is that clear? Now we have converted in terms of cosec y. So instead of cosec y, what can we write? X. Okay. So or d by dx of, you should write instead of y, you should write cosec inverse x, isn't it? So it is cosec inverse x is equal to, it is cosec inverse x is equal to minus 1 upon, what is cosec y? Cosec y is x, right? And root over, what is cosec square y? It is x square. It is x square minus 1. So it is proved. Similarly, you can prove formula number 18. Okay. So this much is for today. So in the next class, we will do some problems. In the next class, we will do more problems, right? That is, you have to do differentiation of the function. So you should know all the formula from formula number 1 till 19. So while doing problems, we need all these formulae, right? So in the next class, we'll do more problems, that is differentiation of the function. Okay, so this much is for today.